Hello, this is Martin from the Math Center, and right now I'll be going over the domain and range of composition functions. So we have two functions. F of x is equal to x plus 2 over x plus 1, and g of x is equal to 2x plus 3. So we want to compose f of g of x, which is equal to 2x plus 3 plus 2 over 2x plus 3 plus 1. So what I did is I just plugged in g of x for each x variable in the f function. So we can simplify this into 2x plus 5 over 2x plus 4. And so our composition, f of g of x, is 2x plus 5, 2x plus 5 over 2x plus 4. And so we could just, now we have to find the range, or the domain of this function. So we notice that we have this rational function, and we know that we cannot have a 0 in the denominator. So we have to find out the x value where we have 0 in the denominator. So we set the denominator equals 0 and solve for x. 2x is equal to negative 4, and x is equal to negative 2. So when x is equal to negative 2, we have 0 in the denominator. So in interval notation, we have negative infinity to negative 2, union negative 2 to positive infinity. And this is the domain of the f of g of x function. Alright, for the second problem, we have f of x is equal to 1 over x, and g of x is equal to the square root of 3 minus 2x. So we're composing f of g of x, and so this composition function is equal to 1 over the square root of 3 minus 2x. And so when we're trying to find the domain of f of g of x, we have to take into account the restrictions of the f function and for the g function. So let's start off with the f function. We know that the denominator cannot equal 0, so we have to start off by setting the square root of 3 minus 2x equal to 0. And now we solve for x. So we're going to take the square root of both sides. That gives us 3 minus 2x is equal to 0. We're going to add 2x to both sides. So we have 3 is equal to 2x. Then we're going to divide by 2 to both sides. And x is equal to 3 over 2. So when x is equal to 3 over 2, we have a 0 in the denominator, so we have to exclude 3 over 2 in our interval. So for the second restriction, we can on g of x, we can't have a negative in the denominator. So we have to set the 3 minus 2x greater than 0, because it has to be positive. So 3 minus 2x is greater than 0. And now we have to just solve for x. So when 3 is greater than 2x, divide by 2. So x has to be less than 3 halves. So when x has to be less than 3 halves, we have a positive number in within the radical. And when x is equal to 3 halves, we have a 0 in the denominator, which is not on the domain. So in interval notation, we say that x is from negative infinity to 3 halves, but not including 3 halves. That's why we have the parentheses.